Yeah. Okay, so we'll. All right, so we'll go ahead and get started. It's 2:15. I'm sure people will keep filtering in, but this is how to select healthy materials in a broad way. So the way that we think of materials, we'll share that. We'll share some of the resources we use in terms of how to evaluate even what healthy might be, what might it mean under different rating systems or different certification programs. Would love for it to be an informal conversation, so any questions, any thoughts anybody might want to add, feel free to jump in as we go. Would love it for it to be a conversation and not a formal presentation, especially with the topic as broad as health, because it seems that construction, from my perspective as a construction manager and also a building performance consultant, health is probably, if not the most challenging or difficult or broad category of construction to define. There's a variety of different definitions and metrics that you can utilize for health. And so I showed this photo. We discovered this photo in the Onondaga Historic Association. We were working with the City of Syracuse Land Bank trying to do building salvage, because as builders we came out to a lot of project sites that had a perfectly good house that a client most times just wanted to demolish to construct something else on. And so when we looked at the quality of materials in a lot of these old homes, no one had really had any memory in the city of Syracuse or the surrounding community of deconstruction, salvage, or reuse. And so when we started to dig through the historical archives, we found this photo. So this photo is 1920 Syracuse. That's the Hotel Truax, 4-story luxury hotel, weighs 12.4 million pounds. And what the original builders and engineers did was move this hotel across the street over a span of 3 to 4 months, spin it 180 degrees and drop it down on its original hand-cut stone foundation. And so the twist of the story for this is the hotel actually never closed during the move. The whole time it remained open, so hot showers, all the amenities that a luxury hotel would offer in the year 1920. And so we as a community in the city of Syracuse forgot that builders had the ability, and not only the ability, but they did it. That's actually a documented, case study in the Historical Association of what they valued from a material perspective and what just made sense at that point. Because the other choice would have been, well, let's just demolish it, maybe salvage, recycle some of the brick, grind it up for road base, or do something else with it, and then build something new. And so today a lot of the thinking is in terms of healthy materials or net zero buildings from a new perspective. But so we saw this and saw the values and thought that this kind of connected to health in the ways that we'll kind of move through now.
So what happened to that building, Josh?
Oh, so yeah, so within 2 decades it was demolished to make way for our parking lot. So that's kind of how quickly our community forgot about the value of building salvage, reuse at that sort of scale. And we'll have a case study a little bit later in the hour that shows how we tried to recreate that memory. So those are 2 of my 4 kids in a pond at our house. And so when we think health, or I think health for what we build or the projects we work on, we've heard a lot of climate change, and we always hear, I think, a lot of climate change, but more global environmental change. And what that global environmental change looks like here in the Adirondacks or down in Cazenovia, New York, where I live and work, or in the city of Syracuse, or wherever we might go. And so we think of health in terms of adaptive health, and how can you preserve health through time. So me as a dad, how can I ensure my kids stay healthy from the materials I bring into our house, the insulation, the air sealing, the floor finishes, whatever it might be, but at a larger scale, that when we're part of a community, how do those different things interconnect? And so one of the things as a builder that I like to do these presentations because I tend to learn more in the conversation with the audience, because health is such a complex field and everyone's perspective, I think, is valuable in sharing with it. Because with this metric alone, 82,000 industrial chemicals in common use, and we don't have good information on 85% of those. And so when you think about being a builder or remodeler in a global supply chain, it's almost impossible to verify some of the ingredients or components that go into materials. A good example, again, for the building reuse, It's why in New York State under Code Rule 56, you have to do a pre-demolition or pre-abatement or pre-renovation survey in all houses regardless of age. It's not just the post-70s when asbestos was outlawed in the United States, because if you go even into newer homes and you talk to the environmental abatement firms, they're still discovering asbestos in the sheetrock plaster of new homes, because in the global supply chain, asbestos is not outlawed. It was only here in the United States. And so as a builder, it's almost, you feel as if you're blind sometimes when you try to figure out what a healthy material might be when you go to a global supply chain. So one thing we'll talk about a bit is how you kind of relocalize or kind of shrink and kind of make it a meaningful, very smaller place-based supply chain. But this is sort of the environment that I think we all work in, that it's very difficult to get accurate information on what exactly is going into our building materials and products. So you can test it, unfortunately. If you were to say test your blood, there'd be more than 100 industrial chemicals of those 85,000 in your bloodstream. On average, 120, 130 when they test the cord blood of infants or babies before they're born, 200. And so when you don't have good information on 85% of the industrial chemicals that are in common use, including our building supplies, then it becomes incredibly difficult to talk about health. And so you have to start really from a position of humility and kind of as close to home as you can to try to understand it. Because along with the fact and that statistic that 85% of chemicals we really don't know that much about, we have absolutely no idea how those chemicals interrelate with each other. The synergistic effects of two different chemicals. So even if you have one chemical, for example, that is below some scientific safe level, taken in isolation in your bloodstream, there's really no good information on how that one chemical interacts with the other 100 that you might have. And so some of it's from pesticides we might apply to lawns, but a lot of it's from building materials and the dust that both adults and humans might ingest as they crawl across the floors that might scuff off a carpet or a flooring finish. So it really does come down to us, I think, as builders and remodelers to take some responsibility and try to understand exactly what health might mean. So I include this slide because I think there's so much focus today on climate change and global warming and greenhouse gases, but the adaptive health framework that we use actually looks at climate change as only one of 9 global problems from a global change perspective. And actually, I think biodiversity loss is significantly worse. So this is a photo. Has anybody heard of coal top mining in the Appalachian? Mountaintop removal, yep, thank you. Yeah, so that's one of the mountains, one of the more than 500 mountains that have been essentially, well, that's the process of extraction of coal to power the, perhaps the lights in this room. So when we talk about electrification as a strategy in New York, if the source of that electricity comes from this ecosystem, we can start to measure how that sort of extraction method impacts health, or how that might lead in the manufacturing and production of a building material. So we can look at how the communities in that region, it's the world's most biodiverse freshwater ecosystem. Most of the communities have been there for more than 7 generations and are closely tied to those mountains, are as much the identity of that community as maybe the 46ers are up here. So if you imagine if there was coal in the 46ers up here, would that be an acceptable energy extraction strategy or a way to make building materials here? So the whole idea of a way, cradle to cradle, comes in a bit. But biodiversity loss is really the one that honestly probably concerns me most in terms of the health of my children, because even as a builder and construction manager, our homes, even if we talk about systems that can purify the indoor air or generate more electricity beyond net zero, or purify water through a gray water or black water system that you might include, ultimately, everything we build, we rely on nature for. So all those services that nature provides for free, drinkable water, breathable air, a relatively stable climate, that's not accounted for in the price of anything that we do. So clients expect these sort of things after we construct a house, but we don't provide those services. We're not the ones that generate that fresh air or create that water. It's nature. We put the well in and the septic, and we just trust nature to handle it. So this is where we look at health and building materials from this sort of perspective about biodiversity loss and the manufacturing impacts of where not only just energy, but how we're using that energy to make what we're making for building materials. Resilience is another area we do a lot with. So you could specify the perfect healthy material in isolation, but if you don't look at the house as a system and consider where you're building in a way that is going to adapt to whatever that change is, whatever the source of that change might be. Here it's a hurricane. This was, I think, right after the hurricane in Florida recently. This was a photo from the New York Times of the one house where the clients told the architects and design and construction team, you know, forget the FEMA 100-year flood, forget the category whatever wind speed for the hurricane. I want you to accommodate, I think it was a 275 mile per hour hurricane event. And so really the idea that the sort of change we're going to face in the materials we select from a health perspective, we have to understand what that future change is going to look like. How much more inches of rainfall or temperature variation or what it might be, because if we were even to try to find a perfect, you know, whatever that perfect healthy material might be, unless it can accommodate future change that isn't, you know, kind of the same scale and magnitude of past change, then it may not be so healthy in the future, especially if you look at some of the, say, for example, EPA guidance on how toxic floodwater is. So if you think about the Binghamton and the Susquehanna floods that have happened recently, the floodwaters are classified 4 different categories in terms of toxicity, but of all the stuff that enters floodwater, it gets incredibly toxic incredibly fast. So even if you design your buildings to wet and then dry, or accommodate different types of flood proofing, it still may be absorbing all of the biological toxins, the wastewater treatment plants that overflow, the combined sewage and stormwater that overflows, the industrial chemical plants that get flooded out. Unless all of those things are thought about, health really vanishes pretty quickly after an event like this. There's you.
Now you want me to say something.
So outdoor pollutants can penetrate indoors. There are still states that don't have infiltration rates, right? State of California. There's no air leakage requirement in the state of California. And what they've learned over the years is something I heard actually earlier in the presentation just prior to this, is that our buildings are acting as filters, especially the buildings that are not tested for air infiltration. So we need to recognize that. So the products that we select even for the exterior wall assemblies are part of the indoor environment. And these are having sometimes a bigger impact than the indoor air and the materials and resources that we place inside that thermal and pressure boundary. So most of the person's exposure to outdoor air pollution actually occurs indoors is a true statement. It's something that we don't recognize up here in the cold countries where we feel that we're air sealing everything up. We still have to induce mechanical ventilation. And the codes are pretty specific. They're silent on some issues, but the mechanical side of the code says anything less than 5 ACH 50 has to have mechanical ventilation. And the energy side of our code says that every house that's permitted after October 3rd of 2016 has to be 3 ACH 50 or less. So that means we need mechanical ventilation. So that's a whole different topic here, but the important thing about this is if we're going to induce mechanical ventilation, where's the safe air come from, the healthy air? You know, if you're on a street, if you're in an urban neighborhood, we can't get that. Sometimes as simple as putting a fresh air supply out in the rear of a home where we think it's safe because we don't want to be on the road or the driveway side, we end up we're putting it directly above someone's grill on a deck. And we're actually bringing all that contamination in when someone grills air all the time. So it's pretty important about what we do. So, you know, I hear Stiebrick's name mentioned quite often here, and I think he's the one who'll come up with the sequencing, right? And the sequencing is first, don't bring any products inside the living environment that you know are bad. Most of these we know, we can identify quite easy, but don't bring it in. Keep the sources outside. Second thing is ventilate. And by ventilating, that is open the windows and ventilate. That's not necessarily mechanical ventilation, but only if you can utilize it through the proper filtration. But filtration's always last. And when we go to these events, lots of time exhibits and everything else, we find out that They're pressing the MERV and the HEPA filters, and actually that's absolutely the last thing we should be concerned with. So first, don't bring it in. Second, ventilate it. And third, then try and filter it. And there's all sorts of things that get past those filters today, right? Because the smallest particles that do get past it are the particles that enter to alveoli of our lungs, right? And that's what's causing our damage.
And so that's another key point. When we start to look at more airtight buildings and look at passive house FEIS level performance, which is really fantastic, that's where I think when it's a more tightly sealed indoor environment, the material selection becomes absolutely critical to what the materials and finishes. So here's one of the more stringent. Has anybody heard of the Red List International Living Future Institute? Utilized part of the Living Building Challenge. So basically, they've drawn a line to say, not only let's not do just less bad. Let's not look at reducing just the amount of cancer-causing chemicals or VOCs or formaldehydes or that in a product, but what does good look like? So it's is a really bright line. They say any of these chemicals can't be included in any of the products, and you need to go to the manufacturers and essentially get documentation that proves it, that verifies it. And I think this is ultimately where industry is going to move to more and more when health is integrated into codes and rating systems. And they want to think the same way like with food. So if anybody is interested in what's in their food, you can go and you can pick the product off the shelf, look at the label, and you might not understand the chemical. I certainly don't when I look at the chemical names of even natural or organic materials. And it's funny to see sometimes when you look at the chemical name of something that's incredibly healthy, but if it looks long and scary, then people assume it might not be. But so same thing with a building or a material or a product, that you should be able to pick it off a shelf or ask the local building supply to say, show me the label for this product. I want to make sure that none of the 50 red list chemicals are on it, or I'm concerned about formaldehyde or phthalates or whatever it might be. And so this is another kind of the idea of transparency, of just provide the information, then people can make an informed decision. A good example there, and Dad can probably tell this one better, but it was probably 20 years ago when we selected one of the first low VOC paints. So semi-volatile organic compounds boil basically at room temperature. VOCs connected to asthma, allergies, really became the first bad guy in indoor environmental quality 20 years ago. And so we did a demonstration project that measured indoor environmental quality. Thought we were doing something really, really good. And first, unfortunately, the product failed, so we had to go back and repaint the house again, which was okay. But worse, we had actually attended a research seminar with the world's leading indoor environmental quality expert from Denmark. And I think it was you, Ole Fonger. And so I think after that session, much like a conference here, Dad had told him, hey, we just did something really good with a research project. We selected a low VOC paint. And he said, go back to the old stuff. The plasticizers and the phthalates that are in low VOC products. And again, I'm not making a statement on any specific product that's for sale today at all, but at that point, he said, you're doing worse by going to the low VOC alternative because of the phthalates and plasticizers that are in it from a human health perspective. So just go back to the other stuff. And so that's a frustrating thing as builders, because I think we are, anybody who does construction here understands that you're really bombarded and overloaded with, one, a lot of marketing, which is helpful and appreciated by the product suppliers that we use, but it's also very difficult, unless you have a PhD in human health or environmental health, to understand what it all means. And not only what it means in isolation, but how do you integrate it into a system, and so that it still performs.
So, just a little bit about Ole Fonger. He was, before his death, he was the foremost indoor air quality specialist. Most of his research was done on islands, so he had a contained environment where he could test in and test out quite effectively. And he was revered in the indoor air quality by everyone. Everyone who had any notion of indoor air, Ole was the go-to guy, right? So Syracuse University hired him. They made him a research fellow, gave him quite a bit of money to come over, I believe, to teach for 3 weeks. He actually died over here, unfortunately. But when I was sitting in that audience, so here's the world's renowned indoor air quality specialist, and only 20 people showed up, I got to ask that question about the paint. And what he looked at me was like, forget about the water-based paint, go back to the petroleum-based, they're less harmful to you. And he was talking specifically about the phthalates that he did a lot of research on. And it was 10 years after that that the ban on phthalates in children's furnitures, toys, pacifiers came about. So he was that far ahead of the market. This guy was a leader in his field. And the failures that we had is actually the water-based paints could not cover the tannins in a popular product because it was a painted wood. So we had to go back in and spend over $3,000 to repaint that house. So it wasn't so much the repainting that we did, but we certainly used a different product when we went back and had to do the repaint. So,
What was his last name?
Ali Fanger, Fanger.
His testing protocol is still used by most of the rating systems when there's a lot of rating systems now are starting to call for indoor environmental quality testing, and it's still his methodology that's utilized for that.
They're from some like 45 years ago, I believe. The other thing that, Josh showed that picture of mountaintop mining. And so it's interesting that in our business as builders, and I know there's some stonemasons in the room here, and there's some gorgeous, drop-dead gorgeous stone here right in the Adirondacks. We looked at the South Bay quartzite that Mike Finney showed us on his house. There's some really unique granite on this building right here. But the silica rule that just came out recently, in the last 6 months, I believe, that came from the mining industry. Who would have known that as the coal gets harder and harder to get out, they actually started grinding more rock than coal. And the miners down there from an early age, I think the age limit went from 32 to 45, were being found. There was an epidemic in West Virginia of these miners who were getting black lung disease, and no one could understand why until they finally figured out it was because they were grinding more rock than coal. So from that finding alone, that's what stimulated OSHA and their silica rule. So now we're not allowed to cut stone without proper ventilation, proper mass, wetting it down. It takes a lot more effort to lay one piece of stone now than it did literally 6 or 7 months ago. But that's human health in the products that we've grown up with, right? This is something we've all used, we've all done, and we've all breathed. But now it's a rule. It's a requirement in our field.
So just the next few slides are some resources that are out there. Unfortunately, a lot are subscription-based. You have to pay to utilize them, but there's a lot of good public health research also. So I'm not sure if anybody's familiar with Healthy Building Network. They've been around for a very long time, independent source of healthy building products. So that's a place to go for information. They have the Pharos database that continues to be populated. Another, Building Green was the first independent, source. Has been around for a very long time. How many people know about Building Green? Okay, great. Yeah, because I would always assume that people did, and it seems that it's true, but it's still a lot of people aren't aware that these product databases are out there. So just another source. And this is where we started to look deeper into the science itself to try to understand it. And a lot of scientists are actually now in environmental health community seeing the dangers of chemicals such as phthalates and how they enter products and the impact on children's health or our health, and trying to make more pragmatic frameworks that we can take and use in a day, that you don't have to really do an informal master's degree or something to try to understand it. So a lot easier. So this is one network that shares a lot of work. Closer to home, the Harvard School of Public Health put a really good guide out in terms of what constitutes a healthy building. And again, if you take a systems approach, it's not just the material, it's how all the different materials are integrated into the system. And not only how the materials are integrated into the system, but also the ventilation, the air quality, moisture, how your building envelope is going to handle all those different issues. One thing here I think that's really fascinating to me is they shifted from thermal comfort to thermal health, and looked at not just how thermal comfort and most focus is essentially on comfort, but they broaden that. And so this is like a 9 to 10 page PDF that you can download with a summary that says, hey, here are 4 or 5 different things to consider as you construct a healthy home. And then with footnotes to all the research that underlies it. And this kind of brings it, we like, in our projects, that I can stand here and tell you that it's not what I think healthy is. And who really cares what I think healthy is? It's more so, where's that science-based third-party source where we can talk with clients about to say, here's some research and here's why we selected this material versus that material, or this ventilation strategy versus that ventilation strategy, and why it might make sense to pay a little bit more if you have 4 kids that are going to be in that space than it would be otherwise. So that's a great resource. So, ultimately what we do is, and this is where our LCA, and I think in the Adirondacks, people, especially this community, builders and subcontractors and architects, understand that when you go on a site and actually have to build something, you're subject to all those sort of natural laws and rules and snow in April and all that stuff. You have to plan for that sort of change. So for us, healthy is basically measured against nature, and how would health be for us within that system. And so we use these patterns actually when we take a look at evaluating any sort of material or system that we would construct. And so we ask these sort of questions in terms of how much energy went into it. This gets into the mountaintop coal removal. So if one other interesting fact about the photo that I showed in the earlier slide is from a website called I Love Mountains. And so you can go to that website, ilovemountains.org, put your building's address in, and it connects you back on a Google map to the mountains that were removed essentially to power the electricity for that specific building. And it also tracks through the whole cradle to gate, that a lot of the Lifecycle Assessment talk about today too. But so we actually utilize this, so local generally, how can that material be recycled at the end of its life, designed for disassembly, reuse. So all of this sort of stuff kind of factors into how we look at health. A little bit more detail there. If anybody's interested, happy to share this. But it's kind of looking at health from a systems-based approach. And so now the case study. So this gets back to the first slide that we had showed. City of Syracuse land bank. And we had encountered this structure that was going to be demolished to make way for a zero energy, LEED Platinum, Syracuse University School of Architecture competition winning home. And so there was a family in this house, and the family that lived in that house was going to move into the new house, multi-generational family. I forget how many people lived there when they asked us to do a building evaluation in terms of how the family lived to develop the program for the new home. And they were just going to demolish it. And we had looked at it and said, well, let's deconstruct it and see what we could salvage and reuse from it. So this house originally was 900 square feet, that front part essentially. You can kind of see the break on the right-hand side of the screen, where it was originally constructed in 1920 as factory housing for the neighborhood for a factory worker at either the typewriter or the car plant that was in downtown Syracuse. Grew to be about a 2,000 square foot house. By the time we ran into it, this was back in 2008. So you look at that and you'd think, first glance, there's really nothing there. There's probably a lot of mold, a lot of lead-based paint, certainly some asbestos, probably some PCBs in the window caulking, chimney caulking, a whole history of industrial use over its life. So just, for $11,000, $12,000, just demolish it, clear the site, and put something new on. And we had actually found there was a nonprofit interested in getting into building performance and healthy building that wanted to learn hands-on deconstruction. And building repair, so we said, as a pilot project, let's go ahead and take it apart. There's certainly embodied carbon and embodied energy in those materials. 50% of any wood product by weight is carbon. So if you're going to landfill this, you have to account for the impact if you're concerned about climate change. If one of your values is global climate change, if you landfill this house that weighs about 214,000 pounds, you've basically just released all that carbon as it decays in a landfill. So you should account for that embodied energy in the construction and the measure of carbon for anything that you build on the site. Because at that point, when we looked at the research said if you just simply landfilled that house, built a home that was 50% more efficient than code, it would take anywhere from 35 to 65 years to replace the carbon lost by landfilling that before you broke even. So that house would need to function at 50% more efficient than code for up to 65 years before you even broke even from a carbon perspective. So what's zero energy to you? What's zero carbon to you? you can't ignore a 214,000 pound structure just sitting there and just not include that in your calculation if you want to be honest about it. So Land Bank said, well, we have no memory of deconstruction. We're really worried that these trainees are going to be injured. They're going to fall off the roof. And that's where I think we as builders said, wait a second, we build this sort of thing every day. There's roofers, there's a process that it's essentially just the reverse of construction. So why can't we just disassemble that by hand and try to salvage what we can salvage? And maybe it'll be a wash. Maybe it'll be the worst idea we've had in a very long time. Maybe we'll look at it as a failure, but let's at least look at it as an experiment and understand how we could utilize those materials. Again, under this broader idea of what health is. So took it apart, took 3 days to deconstruct it down to top of foundation, salvaged 86% by weight, including foundation, but to say that's to sort of game the system a bit because the foundation is the heavy stuff and the easy stuff to recycle and reuse, so you really want to look at any sort of deconstruction in terms of excluding foundations and the heavy stuff. And there we just looked at a market-based approach. Like I said, day one it was down to basically where that big mud sill is. You can kind of see right along here, real big old 6x6 by 30, 34 feet long mud sills. So 3 days we had it basically had it apart versus a day and a half with an excavator and a dump truck. More people, more employment, all that stuff I think factors into the health of a material. But then we asked, well, what can we do to really reuse it? So this is just some of the photos of through the process. Did you want to talk about the materials here at all? Or?
Sure. So one of the things I'm always fond of saying that, this is antique wood, right? So this is what we call true old growth lumber that lives in these houses that we're no longer allowed to harvest from the forest, correct? So the lumber that was in this house had 25 to 27 growth rings per inch. That's an antique piece of lumber. And what we found once we harvested, these were actually the studs, but what we found out with the mud sills, in the old days they used thick mud sills because they knew that where the rot was going to be. So the thicker they are, the longer they lasted. And we actually turned it around. We actually, because the house was a winning competition house for the Syracuse University Architectural School, the architect got $25,000 and we built the house right on site. So we like to say is that the wood that lived on site stayed on site. We harvested lumber, we milled it, and we put it right back in place as flooring in this house. We made cabinets out of some of it, but most of it was better lumber than we can get at the supply yards now. And I'm talking about the good supply yards. We actually have a photograph of the back end of that house that was built, I don't know, maybe 20 or 30 years after that, but you couldn't even stack the lumber up, it was so crooked. It's like some of the places we go now as homeowners, we can't find a straight piece of lumber. This old growth lumber is like just as straight and true as can be. So what Josh likes to say most of the time is that we need to be foresters. So we look at these houses just like a forester would look at the forest and actually understand how much board foot of old growth lumber is in there that we can repurpose, reuse, and reimagine as new products in the house that's going to live there.
And so that's kind of an easy way to simplify supply chain. And so, one of the criticisms here was, well, in a house, potentially not that many contaminants. You can test for PCBs. You can identify lead-based paint. You can do your pre-demolition survey, identify the asbestos and some of the other. But what other chemicals don't we know about that might have been absorbed by that wood product over the last 100 years? And that's where it gets to be a more difficult conversation because, other alternatives to use this wood, for example, as a framing package or whatever of the house you're going to construct, another alternative, you could go buy FSC certified wood in a framing package. But then you're really trusting that third-party certification to ensure that the forests are appropriately managed in those other cultures or those other places. Short of flying to South America to look at how the tropical wood is being harvested somewhere, you really don't know. And so one thing here, it was really nice to just understand it and say test it. And the criticism came up that, well, there might be these unknown toxins that have been absorbed into the product over the years. And I said, well, you need to compare that against the known toxins of phthalates and plasticizers and the other VOCs. And so is this, because the perception was always this sort of, wood is less healthy. You can't reuse that wood because of the lead-based paint. Well, we worked with a local cabinet maker that had a ventilation system in his shop that he had absolutely no concern about bringing lead-based materials in and basically taking lead-based paint off in a way that met all applicable law and reusing it to build some cabinets out of, which I'll show you here. So those were cabinets that were constructed from the wood that was salvaged and reused, and same with the flooring there. We worked with a local barn deconstruction firm that we utilize for a lot of our projects, and he took those old 6x6 by 36 foot long mud sills and resawed them into that flooring. And so actually did a manufactured flooring product out of it, which was really, really nice. And then we went back and said, you know, even from a cost perspective, first cost of deconstruction or first cost of a healthy material is generally higher than whatever that, you know, base alternative is. But if you look at it again from a systems perspective, and you look at the products that are created, the people that are put to work, how can you as a community not hire people from these neighborhoods to go out to do this sort of work, to learn a trade, to learn really a profession, to deconstruct, you know, really at that point there were 2,000 or 3,000 abandoned, deteriorated, vacant homes in the city of Syracuse that were sources of crime, sources of you know, safety for neighborhood children that would play in them and get injured, sources of fire, huge cost to the city. And so when we get a demolition bid of that home, for example, of $16,000, which is basically the average demolition cost for any upstate city, and compared it to deconstruction, we said, you know, for this, we'll do it for whatever the demolition bid comes in at. And Syracuse University stepped in with, I think, another $6,000 of gap funding of what the deconstruction actually cost. And so when we looked at it and ran all the numbers and weighed every pound and looked where everything went, first cost perspective, it cost $6,000 more to deconstruct than it did to demolish. But once you account for all the local workforce development, all the unemployed youth and individuals in that community that were hired, so you, really how can you use health as a metric and kind of relocalizing as a way to recreate that local economy, those local business owners that tend to be, if you're in a community of local businesses, they tend to care for each other and care for the community much more than if it's sort of a global, isolated company. And then you start to measure the carbon sequestration. Again, 50% by weight of any product is carbon, wood product is carbon. So it becomes profitable if you just look at it from a systems perspective. This is another case study. Did you want to talk about this one?
Sure. Yeah. So Josh and I both teach up to the College of Environmental Science and Forestry, and then one afternoon after a class, one of the students came up to me and said, you know, we are abandoning our fish farm that prior to the fish farm used to be a sauerkraut factory. So in the sauerkraut factory, there were 12-foot wide vats that were 12-foot deep, actually 14-foot deep, that had a cypress bottom on them. So all the lumber, come to find out, they actually sent a piece down to Louisiana, somewhere near New Orleans, and found out where they were harvested. So you can count the growth rings easy enough on the boards and figure out how old they are. And the boards, when the tree was harvested, was somewhere around 197 years old, I believe. Actually, it was 187, 190 years old. And the barn that they came out of, where the vats were, had actually been in play for about 80 years. So when we went and harvested this wood that was really just going to get tossed out, we ended up harvesting it, putting it back to use, and here we built a living bridge out of it, where the bridge is actually in place and the vegetation is suspended down in the stream bed to actually clean and purify the water to better than a standards than a tertiary treatment plant can do, a municipal tertiary plant. So these boards are literally a quarter of a century old. They're 250 years old, and they're still using. And we put it right on the water without any sealants, without any treatment, and these boards are still giving us life, right? So this is something that came out of a class. So when we first started harvesting it, it was almost like maybe $1.15 a board foot. By the time we got done, they put it on, I believe it might have been Facebook, someone mentioned that earlier, and it shot all the way up to $8.75 a board foot. That's how profitable it was for true old growth cypress. So, you know, what's living in our barns and our old houses is valuable stuff, very valuable, and we know where it comes from, and we know how it's going to perform. It's interesting, when Hurricane Katrina hit, that The houses didn't suffer from mold and are still standing were the houses that were built out of local indigenous species, cypress. What grows in the swamps can live through any moisture conditions. And this one here still lives.
So that was a, a material decision when we were asked to build this was what other alternative materials could we use to basically carry across a pond as a walkway. The rail was added after because the clients had grandchildren, so it was a safety issue. But it was ultimately, we just want a walkway to span the pond for this, it's called a restorer, so it purifies the water in that pond to make it much easier to purify and drink. Again, kind of that free service that we're trying to enhance for the client. But other materials could have been some sort of plastic decking or some sort of heavy marine grade finish. Or we probably could have talked to some sailboat makers. I don't see Mike in here, but he said he's making a boat. Or no, it's Chris that's making making a sailboat. So we could have called Chris and said, hey, what sort of varnish or finish should we put on any sort of wood product we put on a pond? Or do we just look at something like cypress that happens to evolve and grow in that sort of hot, humid environment that doesn't need any sort of finish at all? So it wasn't even, it made our day a lot easier to not have to evaluate the toxicity of different materials and finishes in this sort of setting, to just pick the right material.
This was actually one of John Todd's ecological designs. He specified the plants, the amount of mats, the biomats that went in, and the plantings. And our idea was to put a walking surface across it so you could actually manage it and keep it in shape, but it purifies the water that comes onto our site.
Oh, thank you. So I think, certainly any conversation on health, we have to talk about where kind of current best practices with rating systems. LEED is an excellent tool, like Mike Finney talked about this morning. Really fantastic guideline. We certainly always urge clients to pursue certification because of the benefit of that third-party verification. It's another set of eyes when you're on a project to ensure that everything is installed as it should be. But so environmental product declarations is kind of the I mean, it's been around for a long time, but it's starting to emerge as a real way to evaluate the benefits of healthy materials. So go ahead.
Sure. So EPDs, how many have heard of EPDs? How many have not? Maybe we should start asking that question. So there are quite a few. So environmental product declarations. There's a series of them. There's a process in place of how you actually manage them. It's in essence a life cycle assessment. There are processes in rating systems like LEED that refers to cradle to gate, because as a building owner, if you're going to sell it, you have no idea what's going to happen after the fact. So they make you do a LCA cradle to gate, so as installed. And there are EPDs that are based on the life cycle assessment in that aspect as well. We like to think that we do the whole gamut, so cradle to cradle, but this is the way it is, and these are the ISO standards, right? So there's quite a bit of history with EPDs, as Josh pointed out, but this is how it works. EPDs being with a product category role. The first step is to look at the product category role, which defines how to conduct the LCA for the product category being assessed, whether it's for carpet, steel framing, or whatever material it should be. They're usually product categories, so you'd see a building sealants are looped into the same LCA, concrete and cement, flooring products, insulation, office furniture, roofing, steel construction products, windows and doors. So this is a fledgling industry as far as rating systems go to, and it's extremely hard to get. As a matter of fact, when LEED or when USGBC released the beta version of 4.1, this is one of the rating part of the rating systems that they put a lot of effort into it because they found out that it wasn't taking hold. No one could actually easily get to achieve a credit point based on the EPDs that were currently on the market. So it didn't stimulate the market like we thought it would, but it's starting to come. So what they did is they relaxed it a little bit. So there are EPDs that are done by companies in-house that you get a certain point for. I believe it's a quarter of a point. There are EPDs that you get out and you're publicly making everyone aware of that LCA, and you put it on a website, and it's been reviewed by the companies that have done the LCA. And then there's a third-party LCA. which is referred to as EPD, Environmental Product Declaration 3. And that's where you get a full credit, and that's where it's been third-party verified. So they've looked at the entire LCA from cradle to gate, and they've verified that these companies that are putting these measures out there have done it correctly and have done it according to the rules. So it's important. So this is the first time ever we have something we can go to, an environmental product declaration, the same way we can go to the supermarket, like Josh said earlier. We can pick up a box of animal crackers, as Rick Fedrizzi usually likes to say, and you know everything that's in that box of animal crackers. Every ingredient is in there and it's listed. We should know that about our products. We should know if there's one of those chemicals in there that are on the red list, if it ends in IDE, ENE, all these things that are accompanied by the benzene ring. You know, we should know that. We shouldn't have to guess that. So that's full transparency. And that's what an environmental product declaration is about, is being transparent with us, not just the builders, but us as the customers, to understand what we're bringing inside our indoor environment. What's coming in inside the thermal and pressure boundaries, it's like I said earlier, that's the very first thing we shouldn't allow in, is stuff that has nasty chemicals in it that are going to off-gas. USGBC has also reacted to and upped the ante on the VOCs, right? So it's not just VOC content now, it's VOC content and VOC emissions. This is a critical aspect because the VOC content is one thing, but what's being emitted from that product as emissions is probably what we really need to be worried for. And what they've done to make it easier to slide into that rating system as far as the VOCs goes is that there's a VOC budget. So if some product or manufacturer or building owner selects something that may not fall in it, let's say there's a place where someone wants a dark stain, so the more pigments in a product, in a paint product or a stain product, the more VOCs it has, that can slide in and be used as long as it falls under a certain threshold. So now for the first time, we've got something we can actually put our finger on. We can identify, and we can go back to some of these systems that Josh showed you, Declare, Trust, and all these others, and actually start sliding in and understanding what's in the products that we're bringing inside our homes. Why are we being forced? And I would say that Mike's going to do some work on the energy codes. I don't know where he went, but what the energy codes are doing to us today, when they tell us to go to a 3 ACH 50, that's half again less than what we had 2 years ago when it was 7 ACH 50. So it means they are so tight and the builders are so worried because we get to test our houses at the end of construction, basically, right? With certain goods and services, we test 2 or 3 days before we're looking for the CO and the people to close so we can get paid and these people get their financing in place and they can move into the houses. So we test these houses all the time. We tested one on the way up here to the Wild Center. We stopped along the highway and did a performance test for a builder, and he failed. The furniture was already inside the house. These people were moving in this weekend. So what's a builder supposed to do when something like that happens? So they learn from that, and what they're doing is they're sealing their houses up so tight because God forbid they're going to fail and they're not going to close in time and get paid, and they may lose the mortgage rate because it's locked in for a certain period of time. And these people who have bought this house have probably sold their house. They have nothing to do. They've got to move out. So we've got to get that certificate of occupancy. So make no mistake about it. These builders are sealing their houses up the best they can because they don't want to fail that test. And when you hermetically seal up a house like that, what we bring inside stays inside. What we cook inside stays inside. You think about radon gases coming into our houses or the fossil fuels that we use in our cook stoves. That's how the state of California is getting their fossil fuels out. They think the hardest thing for them to do is get the fossil fuel from cooking out of their houses. And they're using it and they're basing it on the studies that we've done in New York State. We've known this for 25 to 7 years, that if you have a fossil fuel cook stove, whether it's natural gas or propane, it's going to create carbon monoxide. And unless you got a range vent that's got a full capture hood over that cook stove or your oven, you're bringing carbon monoxide into the house. So they're releasing all these studies finally. The Gas Association, the Gas Appliance Manufacturers Association has depressed these studies for about 28 years now, and finally they're coming out that 50% and more of everything that we test on these cook stoves fail the CO levels. Complete failures. These are brand new stoves. These aren't dirty ones. This is a story we like to tell on Thanksgiving. It's not the tryptophan or the boring football games that are putting everyone to sleep. It's low-level carbon monoxide poisoning. Put a big turkey in a small oven, that's incomplete combustion. The first thing you get out of incomplete combustion is moisture and carbon monoxide. Make no mistake about it. So as we start to seal our houses up, these environmental product declarations become inherent, that we be very careful about what we bring inside our houses.
So we're at the point for questioning, if anybody has any. Yeah, go ahead, Harry.
Would you say a little bit about the difference between?
That's a great question. We've not looked much into the HPDs. So I would, actually, if you want to share, I would ask you to, because I'm sure you would have more to share on that than I would. Yeah, certainly. And it's one of many different ways to compare. And, when you look at the ISO standards that underlie EPDs, even they will, in the standard themselves back here, identify what limits apply. So when you look at an EPD, it's really only as good as how well it was done and how it was completed. And so I think that's probably the take-home message for an HPD or an EPD is that, and this is straight from ISO 14044 of how you complete an EPD, is, certainly those are the benefits. You improve decision making. You have at least some information when you have to purchase a product and bring it into your house to construct it, especially if you've got a third-party testing agent that comes in that is going to test the indoor environmental quality, the indoor air quality of that home. And a lot of that sort of testing is starting to come into different rating systems as a way to verify indoor environmental quality. And so earlier, Mike Finney hit on a really important point in terms of liability. We had done a study with NYSERDA probably 12 or 15 years ago, constructed a very airtight house, ICF construction, and they put all different monitors in it to measure, moisture and, and thermal flows through the envelope, through the building. They also put indoor environmental quality monitors in to measure different formaldehyde levels and all of that. And so for us, as a builder, we constructed it. The VOCs were, this was after we had switched all low or no VOC products, were like this. But then as soon as the family moved in, it was a bonus room, I think above the garage specifically, that just spiked. The VOCs spiked to an unsafe level almost immediately. And so if we hadn't tested that, and say somebody had gotten sick in that house after they moved in because it was so tight, and I think everyone in the room, if you guys are builders and subcontractors, the finger of responsibility, liability would have pointed right at us. You guys used the wrong adhesive, the wrong sealant. There's a problem with some insulation product, the flooring stain. You did something wrong, and now I'm sick. And attorneys don't care whether how it happened. If you've got someone who's sick and can't live in the house that they paid a significant amount of money to live in, then that's a problem. And so luckily there, we said, come in and measure whatever you'd like. And they actually tracked it back to 14-year-old furniture. And so most common thinking there was any sort of off-gassing for a wet applied finish or for furniture, it's why most rating systems do like a pre-occupancy flush. You flush the home of any sort of VOCs, even with furniture, because once a furniture product ages, it doesn't off-gas. And so in that case, if we hadn't tested and tracked it back to that furniture, the homeowner and everyone would have looked at us as building an unhealthy home. And they would have said, you sealed it too tight, or whatever the criticism would have been. But in that case, we had the data to go back and say, we were at absolutely no baseline zero VOC indoor contaminant until that furniture got moved in. And then you take the furniture out, you ventilate it, and sure enough, it spiked back down and went almost to zero again. So in that case, it actually saved us from a pretty difficult process of trying to figure out what would have happened otherwise. Yeah, go ahead.
Boy,
I have not, but I believe I've